This is an illustration of a traveler at a fork in the road, capturing the visual metaphor of Robert Frost's poem, The Road Not Taken. We've all stood at a juncture like this, made a choice, and spent the following hours wondering what would have happened if we had walked down the other path. We do this even with the highest stakes. Consider a family member who smoked a pack a day for 30 years and died of lung cancer. Our minds immediately generate an alternate reality. He would be alive today if he had never picked up a cigarette. The strange thing about that thought process is that we are mourning a world that physically does not exist. The version of that person who didn't smoke for 30 years can never be observed. It is a reality that exists only in our imagination. Other creatures on this planet react only to the observable present. Humans, however, are defined by our capacity to envision the unhappened. Our ability to look at an outcome, compare it to a non-existent alternative, and judge the difference allows us to process concepts like responsibility, blame, and credit. For centuries, this presented a hurdle for science. Mathematics relies on hard data, and it is difficult to quantify a scenario that explicitly never occurred. This limitation follows us into the pursuit of artificial intelligence. When a robot fumbles a task and resets, it is reacting to what is. It doesn't inherently understand what it should have done differently to succeed. Decoding how the human brain calculates these what-ifs is widely considered a necessary step toward achieving machine intelligence that can reason like a person. This is a page from philosopher David Hume's Treatise of Human Nature. Initially, he argued that cause and effect was a simple product of observation. We see a flame followed by heat enough times that we eventually link them together. Hume later realized that observation alone wasn't enough to prove a cause. A rooster crows every morning before the sun rises, but the rooster doesn't cause the sunrise. True causality requires a counterfactual test. If the first object had not been there, the second never would have existed. Modern philosophers like David Lewis proposed evaluating these scenarios by imagining possible worlds. To test a decision, we imagine the most similar alternative universe where a different choice was made and see if the outcome changes. This creates a representation problem. The human brain cannot possibly render and compare millions of infinite, fully detailed alternative universes every time we make a choice. To function, we likely use a highly efficient mental shortcut that allows us to process these counterfactuals without overwhelming our cognitive capacity. This chart shows how some statisticians attempt to solve the counterfactual problem by treating it as missing data on a spreadsheet. They try to match similar individuals, like Bert and Caroline, to predict what one person's salary would be if they had a different degree. But a flat table doesn't account for the mechanics of the real world. It doesn't inherently know that the 4 years a person spends earning a degree is time taken away from gaining work experience. Judea Pearl's structural causal models offer a mental map of directional arrows showing how variables influence one another. To imagine a counterfactual, we isolate a variable by erasing the arrows pointing to it, insert our hypothetical choice, and follow the paths to see the systemic effects. This process of following paths and erasing connections provides a working model for how the brain manages to imagine alternate realities so quickly and consistently. The mathematical language of counterfactuals transforms a philosophical mystery into a programmable framework. Computer scientists are now implementing these causal diagrams into modern robotics and AI systems. By giving machines the ability to erase arrows within their own structural models, we allow them to calculate alternate scenarios and understand the consequences of their actions before they take them. By teaching machines this logic, we are equipping them with the cognitive architecture our ancestors developed 40,000 years ago, the building blocks for responsibility, blame, and regret.